All right, here we've got a great question from a past exam. It says, given f of x equals 1 over x squared plus 2x minus a, find all of these things. First thing to notice is there is a quadratic trapped within a reciprocal function. So it's 1 over a quadratic. That is the first thing I would notice. We're going to have to look at characteristics of both quadratics and then of reciprocal functions in general. So let's start with domain and range. Domain is always the easiest to find because we've got our three rules. We know we can't have the denominator go to 0. We know we can't take the square root of a negative, and logarithms as well. We can't take the log of 0 or a negative. No logarithm, no square root to worry about, so we just know we cannot take have the bottom go to 0. So how do we find what values will make the bottom go to 0? Well, x squared plus 2x minus 8. That's a quadratic that can be factored to find its zeros of x minus 2 and x plus 4. Perfect. So I'm actually going to rewrite the function as 1 over x minus 2 times x plus 4. And you can clearly see that the values of x being 2 or negative 4 would make the denominator 0. So I'm going to say the domain is x is an element of the reals, comma, x is unequal to 2, and x is unequal to negative 4. These are the two values that x cannot be, otherwise we can put any single x value in there. Great, domain is done. If you wanted this in interval notation, it would be negative infinity to negative 4, round bracket, union with negative 4 to 2, round bracket, union with 2 to infinity, depending on what form you wanted it in. Range. This is a tricky one for range, but you can see that we can put any single x value in. So the bottom of this fraction can go very big negative, very small negative, very big positive, very small positive. The only thing that this function cannot become, in other words, what y cannot become, is 0. And the reason for that is the only way a fraction becomes 0 is if the top is 0. Since the top is 1 and there's no x's up there, this thing will never go to 0. So it's simply y is an element of the reals, comma, y is unequal to 0. That's a pretty common one, especially for reciprocal functions as well, because it's always 1 over something, which can never become 0. Great, we're on to B. Intercepts. Okay, intercepts are going to be pretty straightforward. Let's do the x-intercept first. So if an x-intercept is when y is 0, so I'm going to set y to 0. 1 over x minus 2 times x plus 4. That's just the factored form like we did. Multiplied to the other side, you'll get 0 equals 1. I've just multiplied the denominators. Clearly this cannot happen, so there are no x-intercepts. This is in line with the range. Since we said the range can never be, y can never be 0, that's the same thing as saying there's no x-intercepts. The y-intercept, that's where x is 0. So it's f of 0 equals 1 over, I'll go from the original this time, 0 squared plus 2 times 0 minus 8, and that just equals negative 1 over 8. So the y-intercept is negative 1 over 8. Part C, equations of asymptotes. I'll do this in red. There are a couple things going on. First, a horizontal asymptote. We know that if the degree on the top of the fraction is smaller than the degree on the bottom, there will be a horizontal asymptote at y equals 0. That's the same as the x-axis, and clearly that's the case. There are no x's on top of the fraction, and there's a degree 2, or a quadratic, on the bottom, so y equals 0 will be our horizontal asymptote. Vertical asymptotes are always easy to find. That is x equaling the value that makes the bottom 0. So we already said that we can't have 2 or negative 4 on the bottom, so those are both vertical asymptotes. X equals 2 and x equals negative 4. So 3 asymptotes in total, 1 a horizontal, 2 vertical. I'm going to take all this information, toss it on our graph, and it should be relatively straightforward to sketch from there. Okay, so I've summarized everything we found here. I've got my factored form of the function. One last general rule for graphing reciprocal functions. We always want to, if we can, graph the function on the bottom first and then apply our rules for doing 1 over. So how do we graph this quadratic? It's x plus 4 and x minus 2. We know the zeros are at -4. So I'll graph the actual function in blue, -4 and 2, the bottom function, sorry. And then I will apply the actual reciprocal function in green afterwards. So 2 and 4 are my, 2 and -4, sorry, are my zeros. The last point we need to graph a quadratic is the vertex. So we know the vertex is going to lie at the x value between -4 and 2, or the average. So this is -2 over 2, which is equal to -1. So I know my axis of symmetry is at -1. Let's find the y value of the quadratic. So instead of x plus 4 times x minus 2, I'm going to find what it is when x is -1. So -1 plus 4, -1, -2, and that equals 3 times -3 is -9. So my vertex is -1, called -9 down here, and there it is. So you can see that the quadratic, again, this is not our function, this is just what's on the denominator, because I recognized from the beginning that this is going to be a reciprocal function. So what's our rules for sketching the actual function, which I'm going to do in green? Well, first, whenever it's a reciprocal, we put a vertical asymptote through the zeros, which we already knew about because we wrote our vertical asymptotes up there. Horizontal asymptote, where we found that, that's just the x-axis, or y equals 0. So we've already got sort of a good setup here. Then we know that our y-intercept is at -1 over 8. Very small here. Last thing for reciprocal functions is we always want to keep our values at 1 and keep our values at, there's 1 here too. Kind of messed up the alignment there, but that's alright. And keep our values at -1. So there and there. Great, and then it should be fairly easy to set up. We know it's going to go as high as -1 over 9 because it goes as low as -9. You just do 1 over that, and the rest should be pretty straightforward because you just follow the asymptotes through the y-intercept. So that's the middle bit, and we know we're going to ride along the asymptotes here. This should look like a pretty familiar shape as far as reciprocal graphs go. So again, so the green is our actual function, right? Our function that we have graphed or sketched is in green. This is a pretty tough question, but the first thing to figure out is that it's reciprocal. I'll quickly list those rules for writing reciprocal functions. Vertical asymptote through zeros. And again, this helps once you can actually graph what's on the bottom. Horizontal asymptotes at y equals 0. That's just the x-axis. And then keep points at y equals 1 and y equals -1. Because really what we're doing when we're graphing reciprocal is we're going to graph the bottom first and then do 1 divided by those y values. So since 1 divided by 1 is still 1, we keep it. 1 divided by -1 is still -1, and we keep it. That was these points here. Hope you found this helpful. You can always reach out with more questions. Info@arnoldtutoring.com. Thanks.